State of matter can be changed by change in temperature or pressure. Let us see how. First, we will see the effect of change in temperature. Due to slowly increasing temperature, kinetic energy of particles increases and force of attraction between particles decreases. As a result, solid particles which were vibrating at their mean position overcome the force of attraction with other particles and start roaming around freely. In this process, solid changes to liquid and liquid changes to gas. What happens during state change? Let us understand by an experiment. Take some ice cubes in a beaker and put a thermometer in it to measure the temperature. Start heating the beaker with the help of a Bunsen burner. In the beginning, temperature of ice was minus 20 degrees centigrade. Slowly the temperature of ice rises to 0 degrees centigrade, which is its melting point. It means ice will start melting now. By definition, at 1 atmospheric pressure, melting point is that minimum temperature at which solid starts changing to liquid. Temperature remains constant at 0 degrees centigrade till the whole ice melts and changes to water. It means during state change from solid to liquid, temperature remains constant. Now the same process will be repeated while liquid changes to gas. Let us see how. As the temperature of ice kept increasing till it reached its melting point, similarly temperature of water will keep increasing till it reaches its boiling point, that is 100 degrees centigrade. At 0 degrees centigrade, ice started melting. Temperature remained constant at 0 degrees centigrade till the whole ice melted and changed to water. Similarly, at 100 degrees centigrade, water starts boiling. Temperature remains constant at 100 degrees centigrade till the whole water boils and water changes to vapor, that is, liquid changes to gas. Whole process is summarized on the right. From figure 1 to figure 2, only temperature rise of ice, no state change. From figure 2 to figure 3, only state change from solid to liquid, no temperature rise. From figure 3 to figure 4, only temperature rise of water, no state change. From figure 4 to figure 5, only state change from water to water vapor, means liquid to gas, no temperature rise. Now let us see the definition of some keywords related to this process. First one is melting point. At 1 atmospheric pressure, the minimum temperature at which a solid melts to become a liquid is called its melting point. Second one is fusion. The process of changing a solid to liquid state is known as fusion. Third one is latent heat of fusion. Let us understand the latent heat first. We have seen in the above experiment that continuously supplying heat does not always change the temperature. During state change, temperature does not change. So what does heat do in this phase? It helps in melting the ice and boiling the water. It remains hidden, so it is called latent heat. Latent heat of fusion is defined as the amount of heat energy required to change 1 kilogram of solid to liquid at atmospheric pressure and at its melting point. Next one is boiling point. At 1 atmospheric pressure, the temperature at which a liquid starts boiling is known as its boiling point. Next one is vaporization. The process of changing a liquid to gaseous state is known as vaporization. Next one is latent heat of vaporization. It is defined as the amount of heat energy required to change 1 kilogram of liquid to vapor or gas at atmospheric pressure at its boiling point. The process of changing ice to water vapor is plotted on the graph as shown in the figure. At point A, ice is at minus 20 degrees centigrade. From point A to point B, temperature increases to 0 degrees centigrade, which is melting point of ice. From point B to point C, ice changes to water and temperature remains constant at 0 degrees centigrade. From point C to point D, temperature increases to 100 degrees centigrade, which is boiling point of water. From point D to point E, water changes to water vapor and temperature remains constant at 100 degrees centigrade. From point E to point F, temperature of water vapor increases. By heating, solid changes to liquid and liquid changes to gas. By cooling, gas changes to liquid and liquid changes to solid. The process of solid changing to liquid is called fusion. Liquid changing to gas is called vaporization. Gas changing to liquid is called condensation. Liquid changing to solid is called solidification. It is possible to change solid directly to gas or gas directly to solid bypassing the liquid state. The process of solid changing to gas is called sublimation and gas changing to solid is called deposition. SI unit of temperature is Kelvin, which is denoted by letter capital T. There are two more units, Celsius and Fahrenheit. Numericals based on temperature calculation in these units are asked. These two formulas will be used. We will see numericals in next episode. We have seen effect of change of temperature on a state change. Now we will see effect of change of pressure on a state change. There are two cases when pressure is increased and when pressure is decreased. We will see case 1 first. This is a cylinder, this is a piston and gas is filled inside it. If you push the piston down the cylinder, pressure on the gas will increase, the distance between particles will decrease. Slowly gas will change to liquid and liquid to solid. By this process, carbon dioxide changes to solid carbon dioxide, which is also known as dry ice. If you pull the piston up, pressure on the solid will decrease and a state of solid can be changed to liquid and then to gas. That is, solid carbon dioxide can be changed back to carbon dioxide gas. Now we will understand what is evaporation. We know that particles have kinetic energy. Due to this, in case of solids, particles vibrate at their mean position, whereas in gases, they roam around freely. In case of liquids, a small fraction of particles at the surface absorb heat energy from the surroundings and gain enough kinetic energy to break away from the forces of attraction with other particles and get converted into vapor. This phenomena of change of liquid into vapor at any temperature below its boiling point is called evaporation. There are four factors that affect the rate of evaporation. First is surface area, second temperature, third humidity, and fourth wind speed. Evaporation is a surface phenomena. If surface area is increased, evaporation increases. For example, while drying cloths, we spread them out. By increasing the temperature of the surroundings, more particles get enough kinetic energy to evaporate. So, rate of evaporation increases. Humidity means amount of water vapor present in the air. If humidity is more, air cannot hold more water vapor at a given temperature, so rate of evaporation decreases. If the wind speed is more water particles move away with the wind, so rate of evaporation increases. Evaporation causes cooling. Particles of a liquid absorb energy from the surroundings and get evaporated, making the surroundings cool. Now let us see these two questions. Why should we wear cotton cloths in summer? The answer is, in summer we sweat more. Cotton is a good absorber of water. It absorbs sweat and exposes to air to evaporate. As an effect of evaporation, our skin feels cool. Second question is, why do we see water droplets on the outer surface of a glass containing ice-cold water? The answer is, the water vapor present in the air when comes into contact of outer surface of the glass loses its kinetic energy and gets converted to liquid state, which we see as water droplets. In the next episode, we will see the question answers. If you have any doubt, join our Discord server. Please subscribe our channel if you haven't done so far.